Hello, my name is Bergrún Óladóttir and I'm a Tephra chronologist, and in this video we will show you a Tephra section east of the Katla volcano and what we can do with Tephra layers. So what do we want to get out of working with a Tephra outcrop like we have here? By coming to a place like this and working with the Tephra layers, we can get information on the explosive eruptive history of volcanoes. And here we have a lot of Katla history. If we only want to know how often a volcano has erupted, it's enough for us to analyze the Tephra layers and find out how many layers are here. And of course, if we want to get the complete history, we have to go all around the volcano that we are working with. If we want to find something out about the volume of individual layers, it's not enough to come to one place. Again, we would have to go all around the volcano. We would have to identify the Tephra layer we are working with in each outcrop and measure its thickness in each place. And then we would have to correlate between outcrops to get individual volumes. So that is quite a lot of work. So here we see a very typical soil section in this area east of the Katla volcano, and we have quite a lot of Katla Tephra layers. Most of the layers here are from Katla, and so this is what it looks like when you find the outcrop before you start to work with it. So this is basically the first step, trying to identify the place where you want to work. So the second step, when you have located an outcrop you want to work with, is to find out what Tephra layers you have in the outcrop, if it has the time period you are looking for and stuff like that. So when you see an outcrop like this, you look for something, some of the Tephra marker layers we have. And just without doing anything, here we see that there are some white grains, so this would be a potential Tephra marker layer. Another thing we see here are those grains here. This looks like a promising place, and then we would just have to have a look and see what it looks like when we clean it. So we have those two layers here and we want to see what they look like. So we just clean this and we see that this is a nice Tephra marker layer. But to find just one Tephra marker layer is not enough, because then we don't really know where we are located. So we need to find more to be able to completely find where we are located in time. So we just continue to clean, and here we see another beautiful Tephra marker layer. So those two layers are from Hekla. This one is called Hekla S and this one is Hekla 4. And so when we find those two together, it's a good place. So now we know where we are located in time. So everything above, of course, is younger and below is older. Now we have cleaned some part of this soil section. Actually, we have started, if we would go all the way up there, we would have the settlement layer, which is a Tephra layer that divides between historical and prehistoric time here in this area of Iceland. And what we are looking at is Tephra layers, as I have been telling you. These brown things, this is the soil, and then all the black or brownish black lines are the Tephra layers. In this area, most of the layers are from Katla. Some of them are from other volcanoes such as Hekla. So this is one of the silicic Katla Tephra layers that is used as Tephra marker layer here in this area. And they have kind of this special grain type, needle-shaped silicic Katla grains. Sometimes they are called silk, sometimes they are called needle layers because of this grain type. And this, however, is Hekla grains. and you see the difference of the grain types. So this is silicic Hekla and this is silicic Katla. So when we have located the place we want to work with, we have to measure the soil section. And either we start at the top, it's best to start at the top, or at a known Tephra marker layer. Like here we would start with this silicic Katla layer, which is called upper needle layer, and it has been carbon dated, so we know the age of this layer. And we measure the thickness of the layer, and we describe the color and the grain size within the layer. And then we measure the soil thickness between layers, and we go all the way down to wherever we want to stop. And it's really important to measure the thickness of the soil between the layers, because we use that to calculate age of the layers between dated marker layers. Like here we would have the age of this layer here and the age of this layer here, the lower needle layer. And then we would calculate or use the measured thickness of the soil between the layers to measure how much soil was created between the dates of those two layers. And like that we would calculate the age of each Tephra layer. When we are doing this, it's also very important to know what thickness we are measuring. Like here we see that we have been cleaning this outcrop not directly perpendicular to the grains. So when we are calculating or measuring, we have to make sure that we have the correct thickness, but not like visual thickness of both the layers and the soil between the layers. So we will have to make sure that the thickness that we are measuring is the correct one. And we can do that by cutting like this into the outcrops, and then we see that the thickness of this layer is about 14.5 centimeters, but not, 16 or 17, like if we would just measure it like this. So this is very, very important if you want to calculate volume. Also, if you want to work with the volume, then of course one outcrop is not enough, so you would have to find maybe, depending on the size of the Tephra layer you're working with, maybe 40 to 60 outcrops. And then you would have to find exactly this Tephra layer in all of the outcrops, and based on those measurements you would be able to calculate the volume of your Tephra layer. So when we have described and measured all of the outcrop, like here in this basaltic layer we would describe the thickness of it, we would indicate that it seems to be a little coarser grained here in the lower part than in the upper part. It also seems to have quite a different color, so it's more grayish here than blackish up here. So all of these little details we have to note. Then based on what we want to do with the samples, we sample all of the Tephra layers to be able to either analyze its chemical composition with the microprobe, or we might want to do total grain size analysis. It really depends on what you want to do with the sample, how you are going to sample the Tephra layers. If you want to sample it just to know from what volcano it comes, then you just need to take a small sample. Well, this is quite a large sample, but like if you're working with these small layers like this one, then you would just sample it like this and try to get maybe a teaspoon of material. You always try to get a representative sample of all the layers, so from the top to the bottom, but it's also important to not contaminate your sample with the soil. Especially here in Iceland, since the soil is really volcanic and we have a lot of glass grains in the soil in between. However, if you would want to do total grain size analysis, you would have to make sure that you have a sample from the top and all the way down to the bottom, and you would try to do a kind of a bulk sample. So you try to take a representative sample like this and make sure that you have all the grains that are lying in the bottom. Like here, it's obvious that there are some coarse grains lying down here, so it's really important to get all of those grains in your sample if you're doing total grain size analysis. So like this layer, when you are sampling this, you would have to decide how you would want to sample this. Often I would sample this as part A and part B of the same layer, just because of the color change. So here it's kind of blackish and more fine grained than this grayish black lower part that is more coarse grained. So we would give this sample a number and note it in our field book. So in our section where we have measured everything, we would give this layer its sample number. Then the bag would just be marked with the name of the outcrop. This we just call hemra, and we would put the date of the sample, what is 29th of August. And then we would say sample number, let's say 2A. And this would be 1 because we started the measurement here, and then this would be 2A and 2B. So we're trying to take this part here and this part here. We don't want to have any contamination from upper layers, and as the outcrops tend to dry, often material from above is getting rolled down over the samples you are trying to take uncontaminated. And try to get all of it into the sample bag, which is not going so good. And then we have our sample, and this we can take to the lab, and we would have to dry it and sieve it and put it into plugs for chemical analysis in the microprobe. And when we have done that, then we know exactly where this Tephra layer is coming from. And we would expect to get a Katla chemical composition of this material. So to summarize, there are 3 main points. Number 1, you have to know why you are working in the outcrop, and based on your goals you have to do the measurements and your sampling in the correct way. Number 2, you have to know where in the stratigraphy you are located. Number 3, you have to know how many outcrops you need to achieve your goal. And then, of course, it's really important to remember to write down all the data you are measuring, and to remember to give the samples you're taking correct numbers. And last but not least, enjoy life in the outcrop. Thank you. If you want to learn more about our Tephra studies in the Katla region, you can refer to those publications.